Hello, welcome to Quality Improvement in Math Education Project video based presentation 2019 on the topic linear equations. My name is Mr. Saujanya Bakare. My registration number is MTE075. I work at Indrani Vidyamandis Untitled Chapter at Talegaon Dabhade, Taluka Bawad, District Pune. Professor Inder Kerana and Professor Santosh J. Karpure guided for this project. They are from IIT Bombay. Under this linear equation topic, we are going to see the application of simultaneous equations and to solve word problems based on linear equations in two variables. In this presentation, we are going to have mainly three phases. First phase is observe and explore. Second is define and prove. The third is apply and evaluate. Let's have some recap. What is the general form of the linear equation two variables? The general form is ax plus by plus c is equal to 0, where x and y are the variables and a, b, c are real numbers. Here note a and b is not equal to 0 at the same time. Hence, in these first two examples, where 0x plus 6y minus 3 is equal to 0 and 2x plus 0y is equal to plus 6 is equal to 0 are linear equations where value of either a is 0 or value of b is 0, but both are not 0. But 0x plus 0y plus 0 is equal to 0 is not at all linear equation. What are simultaneous equations? So, when we solve two linear equations in two variables at the same time, we call them simultaneous equations. And we have learned how to solve them by graphical method, by substitution method, by eliminating any one variable, or by determinant, that is the Cramer rule method. Now, some equations which are non-linear equations in the form of 3 upon x plus 4 upon y, say, is equal to 8, where the denominators are not equal to 0, can be reducible to the pair of linear equations in two variables, and we have learned how to solve them. Let's come to the first phase of this presentation, observe and explain. In this phase, we will observe the situation and explore or extract the information. Are you interested in cricket? Let's watch a match between India and Australia, where Sachin Tendulkar is seen that he is playing. It's 4. First boundary, and hence India reached to 6 for 0. Beautifully. 4. Now India has reached to 72. And that's 6. Now India has reached to 96 for 0. With this, India is at 102. Oh, at 140, what happened? India is at 140 for 0. Let's see the result. Let's see the recap. Let's see what is the result. And his arm. Oh. So Sachin Tendulkar's inning come to the end at 140. So, can you identify the Indian batsmen in this video? Yes, they are Sachin Tendulkar and Saurav Ganguly. How many runs scored by them for the first wicket partnership? Yes, it is 140 runs. If Sachin scored 4 runs more than Ganguly, can we find the runs scored by them individually? In this picture, we can see some boys and girls are sitting in the class. If we know ratio of the girls to boys is 2:3, and if 3 girls and 2 boys are added, the ratio will become 3:4. What is the number of girls and boys in the class? What is this? The OMR sheet. So, how many questions were answered correctly by the student? If there are 20 questions in the exam, each correct answer gives 2 marks, each wrong answer -1 mark, and the student scored 28 marks. Observe. What do you see? There are 2 trains. What are the 2 speeds of these 2 trains? If the speed of the first train is 10 km more or greater than that of second train, and if they start from the same spot in different direction, they are found to be 250 km apart in 3 kilometers, and they are going in the opposite direction. Oh, this is the figure of equilateral triangle. What is the value of x and y? If 2x, AB is given 2x minus 1, BC is y plus 7, and AC is 2y minus 3. Okay, in this picture we can see that the boat is traveling downstream, that is the direction of the stream, and boat is traveling upstream. If we know some time to travel certain distance upstream and downstream, and same the other information, second information, can we find the speed of the boat in the still water and speed of the stream. If we want to find the runs scored by the cricketers, find the number of girls and boys in the class, find number of questions answered correctly by the students, or to find speed of the train, boat and stream, all these situations look so different. But can we express the given information in the mathematical form? Yes, we can. Can we use linear equation to find these equations? Yes, we can. So let's now move on to the second phase of our presentation, defined and prove. Now in this stage, we will follow the certain steps which will define as follows. We have to first identify the 2 unknowns, and we have to define 2 variables to be used. We have to convert the given information in the mathematical form. For this, we can use the given information or sometimes the known properties. We have to frame 2 linear equations in 2 variables using these 2 informations or properties. We have to solve the linear equation simultaneously. We have to substitute the value of the values in the given situation, whichever we have found, and we have to verify the correctness of the solution. And we have to write the answer in Word after the verification is over. Now, following these steps, let's try to find the answers asked in different situations. As in the first video, we have to find runs scored by Sachin and Saurav individually. Let's assume that Sachin scored X runs and Saurav scored Y runs. So here we have defined the variable x and y. Now from the first information that both of them scored together 140 run, we get our first equation, x plus y is equal to 140. And the second information is Sachin scored 4 runs more than Saurav. We get our second equation, x minus y is equal to 4. Now solving these two equations by any method, say elimination, we can get value of 2x is 144 and hence x is equal to 72. Substitute this value in any one equation, we get y is equal to 68. Let's do verification. Now sum of 72 and 68 is 140 and 72 is more than 68 by 4. Hence your answer is Sachin scored 72 runs and Saurav scored 68 runs to make the partnership of 140 runs. Now in the situation of to find the number of girls and boys, let's assign that x be the number of girls and y be the number of boys. Now as the ratio of number of girls to boys is 2:3, x is to y is 2:3. By taking the product of extremes is equal to product of mean, we can get our equation x minus 2y is equal to 0. And after adding 3 girls and 2 boys in the class, the new ratio is 3:4. Solving this, we can get our second equation, 4x minus 3y is equal to minus 6. Now solving these two equations, we can get x is 12 and y is 18. Let's verify. Now 12 is to 18 is 2:3, and after adding 3 girls, that is 15 girls, and 2 boys, that is 18 plus 2, 20 boys, the new ratio is 3:4. So after verification, we can write the answer that there are 12 girls and 18 boys in the class. Now here in the third situation, we have to find how many questions were answered correctly. Let's assume the boy answered X questions and he gave Y wrong answers. Now as there are 20 questions in the exam, X plus Y is equal to 20. And as he got 2 marks for each correct answer, so he will get plus 2x marks. But at the same time, he gave Y wrong answers, so minus Y marks will be deducted from 2x and total marks are 28, and second equation is 2x minus y is equal to 28. Solving these two equations by elimination method, we get value of x is 16 and y is equal to 4. Let's do verification. For 16 correct answer, the boy can get 16 to the 32 marks, but 4 wrong answer, 4 marks will be deducted from 32, else he got 28 marks. And therefore the answer is, the student answered 16 questions correctly. Now, come to the situation where we have to find the speed of the two trains. Let's assume speed of the first train be x km per hour and speed of the second train be y km per hour. Now, as per the first information, the speed of the first train is greater than that of the second train, we get our first equation, x is equal to 10 more than y. That is, 10 is added to y. Therefore, x is equal to y plus 10. Therefore, x minus y is equal to 10. Equation number 1. Now, as per the second information that they are going in opposite direction and after 3 hours they are found to be 450 kilometers apart, and we know the fact that distance is equal to speed into time. Distance traveled by first train in 3 hours will be 3x kilometer and by second train is 3y kilometer. Total distance is 450, hence the second equation is 3x plus 3y is equal to 450, or we can say x plus y is equal to 150. Solving this, we can get value of x is equal to 80 and y is equal to 70. As 80 is 10 more than 70 and distance travelled by first train 83s are 240 and by second train 73s are 210. The sum is 450. So the answer is speed of the first train is 80 km per hour and that of the second train is 70 km per hour. Is our answer to this question, speed of the two trains. In this equilateral triangle, we have to find that values of x and y as values of lengths of sides AB, BC and AC are given in terms of x and y. We know the property that all three sides of equilateral triangle are equal. Therefore, AB is equal to BC is equal to AC. Taking AB and BC to be equal and substituting values of AB and BC, we get 2x minus 1 is equal to y plus 7. Therefore, 2x minus y is equal to 8 is our equation number 1. Let's take BC is equal to AC. Therefore, y plus 7 is equal to 2y minus 3. Solving this linear equation in one variable, we get y is equal to 10. If we put this value in equation number 1, we can get value of x to be 9. Let's do verification. AB is equal to 2x minus 1, that is 2 9s are 18 minus 1, 17. BC is y plus 7, that is 10 plus 7 is equal to 17. And AC is 2y minus 3, that's 2 into 10, 20 minus 3, 17. Hence we got the length of all three sides is equal to 70. And it is verified with an equilateral triangle. Therefore, the values of x is 9 and that of y is 10. Now, for the situation, for the speed of the boat in the still water, speed of the stream, these are the two unknowns. Let's assume the speed of the boat in still water be x kilometer per hour and speed of the stream be y kilometer per hour. As per the first situation, and we know the fact that distance is equal to, time is equal to distance upon speed. Here we know the time, so we have converted that formula as time is equal to distance upon speed. Now as it's taking 9 hours to travel 30 kilometer upstream, so speed of the boat while traveling upstream will be speed of the boat in the still water, and as the boat is traveling upstream, the speed of the stream will resist it, and it will, therefore the speed of the boat will be lesser than the speed of the still boat. So the speed will be, while traveling upstream, x minus y kilometer per hour, and when the boat is traveling downstream, it will be x plus y kilometer per hour. Now as per the first situation, time taken by the boat to travel 30 kilometer upstream, that is time is equal to distance upon speed. Distance is 30 kilometer divided by speed x minus y, and therefore time is 30 upon x minus y. Similarly, time taken by the boat to travel 40 kilometer downstream is equal to 40 upon x plus y, and total time is 9 hours. Hence, 30 upon x minus y plus 40 upon x plus y is equal to 9 is our equation number 1. Now from the second information that the boat takes 12 hours to travel 42 kilometer upstream and 50 kilometers downstream, we get our second equation as 42 upon x minus y plus 50 upon x plus y is equal to 12. Now these two equations are not linear equation, but we can reduce them to the linear equation by replacing 1 upon x minus y is equal to m and 1 upon x plus y is equal to n. In equation 1 and 2, we get 30m plus 40n is equal to 9 as equation number 3. Here, we get this equation as 30 upon x minus y, that is 30 into 1 upon x minus y, and therefore it is 38. And 40 upon x minus x plus y, that is 40 into 1 upon x plus y, that is 40 into n. Similarly, substituting in equation number 2 the values of m and n, we get 42m plus 50n is equal to 12. Solving this equation 3 and 4, we can get values of m as m upon 6 and n as 1 upon 10. Now replacing again m is 1 upon x minus y and n is equal to 1 upon x plus y, we get equation x minus y is equal to 6 as fifth equation and x plus y is equal to 10 as equation number 6. And solving these two equations, we got x is equal to 8 and y is equal to 2. Let's do verification. As 30 kilometer distance traveled in x minus y speed, that is 6 speed, therefore 30 upon 6 will give us 5 and 40 upon 10, that is 40 kilometer in in by the speed of 10 kilometers x plus y kilometer, that is 10 kilometers per hour, we get 4 hours. So 5 plus 4 is equal to 9. And from second information, 42 upon 6 plus 50 upon 10, that is 7 plus 5 is equal to 12. After its verification, our answer is speed of the boat in still water is 8 km per hour and speed of the stream is y, that is 2 km per hour. Now let's move to the third and final phase of the presentation, that is apply and evaluate. By following the steps given in the define and prove, let's solve some more word problems using linear equation in two variables. After that, we will see the practice problems too. Let's solve some word problems. The first one is, a plane can fly 1120 km in 1 hour 20 minutes with the wind. Flying against the same wind, the plane travels same distance in 1 hour 24 minutes. Find the speed of the plane and speed of the wind. From the given information in the question, we come to know that there are two unknowns to be defined with the variables. Let us assume that the speed of the plane be x km per hour and speed of the wind be y km per hour. Now when the plane is moving in the direction of the wind, speed will increase and it will become x plus y km per hour. And speed of the plane against the wind will be x minus y km per hour. This is similar to the sum which we saw just now, the boat traveling upstream and downstream. Now, as the fact that time is equal to distance upon speed, when the wind is traveling, plane is traveling by the wind, the distance is 1120 kilometers divided by speed x plus y. Time is 1 hour 20 minutes. Convert this time hour and minute into minutes, we get it 80 minutes. So solving this, we can get our equation number 1, that x plus y is equal to 40. And from the second information, when the plane is flying against the same wind, the equation we will get is x minus y is equal to 40 upon 3. By multiplying 3, which is in the denominator of equation number 2, we can get equation as 3x minus 3y is equal to 10. Solving this equation 1 and 2, we can get value of x is 41 upon 3, that is 13.67 approximately, and value of y 1 upon 3, which is approximately 0.33. Now let's do verification. Now sum of this x and y will give us 40, and x minus y is giving us 40 upon 3. Therefore, the answer is the speed of the plane is 41 upon 3 or 13.67 km per hour, and speed of the wind is 1 upon 3, that is 0.33 km per hour. Now let's come to question number 2. If the length of the rectangle is increased by 12 cm and the width is decreased by 8 cm, the area is unchanged. If the original length is increased by 5 cm and the original width is decreased by 4 cm, then also area remains the same. Find the original dimensions and area of the rectangle. So in this given situation, we can understand that the situation is about the dimensions of the rectangle, that is the length and breadth of the rectangle. These are the two unknowns. So let's say that, let's define the unknowns variable that the length of the rectangle be x and original breadth of the rectangle be y. Hence, area is going to be equal to length into breadth of the rectangle. We can get that original length x into original breadth y is the xy is the original area. Now, as per first information, where the length is increased by 12, the new length is x plus 12, and the breadth is decreased by 8. It means the breadth is now y minus 8. Now its product is going to be area, which is unchanged. So on the right side, we will get the same area, xy. So the product of these two binomials will give us xy. So taking the product and eliminating xy from the both sides, we can get this equation as 2x minus 3y is equal to minus 24. Now from the second information, where the length is increased by 5 centimeter and breadth is decreased by 4, but still the area is unchanged, we can get our second equation, 4x minus 5y is equal to minus 20. Solving this equation 1 and 2, we get value of x is 30 and y is 28. And x into y is 30 into 28, 840. Let's do verification. If when the length is increased by 12, the new length is 30 plus 12, that is 42, and breadth is decreased by 8, that is 28 minus 8 is 20. Product of these is 840. And as per second information, 30 plus 5, that is 35, and 28 minus 4, that is 24. Even the product of these two is also 840. So in both cases, the area remains unchanged. Hence our answer is the original length of the rectangle is 30 centimeter and its breadth is 28 centimeter and its area is 840 square centimeter. Now see the third word problem, where the sum of the two-digit number and the number obtained by interchange in the digits is 154. If the digits in the tens place is 2 more than the digit in the units place, find the original number. Now here the two unknowns are digits used in a two-digit number in tens place and in the units place. So let's define our variable that digit in the tens place be x and digit in the units place be y. Therefore the original two-digit number is going to be 10x plus y, because the digit in the tens place should be multiplied by its place value 10 and add units place. Now the number obtained by interchanging the digits is going to be 10x plus y. As sum of these two numbers is 154. By solving this, we get equation number 1 as x plus y is equal to 40. And from the second information, that digit in the tens place, that is x, is 2 more than digit in the units place. So x is 2 more than y. You can keep this as second equation, or x minus y is equal to 2 as second equation. Solving this very simple equation or looking like complicated sum, we can get value of x is 8 and y is 6. Hence 10x plus y is going to be 10, it's 80 plus 6, that is 86. To verify this answer, the original number, if it is 80, the 6, then the reverse number is what? 68. And sum of this will become 154. And as 8 is 2 more than 6, therefore the original two-digit number is 86. Now using this steps, and we have learned how to apply for solving such word problems, you can solve the further word problems for your practice. These are the some of the examples given for you to solve. The first example is based on the speed of the train. Information is given. Try to solve it as we have solved the previous one. Now, for the second sum, it is given about the numerator and denominator. To using the ratio, try to solve this. Third equation, sum is based on area of rectangle, which we solved just now. Similar to this is the given question. And the last one is based on two-digit number. So solve all these four sums, and you can frame your own questions to solve them and enjoy the decision-making process and solving it by your own happily. Thank you very much for your patient hearing and enjoying the maths with fun. Thanks a lot. Thank you very much.